Hello students, today let us see the conversion of NFA to DFA. There are two methods. The first one is subset construction method, second one being lazy evaluation method. So let us see the first method, which is subset construction method. So we will have to obtain a DFA from the given NFA. The transition diagram will be given to us. So this diagram is having three states: Q0, Q1, Q2. Q0 is the start state, Q2 is the final state. The input alphabets are A, B. So sigma equals A, B, and the states of NFA are Q0, Q1, Q2. Now given the transition diagram, we will make a transition table. Let us look at the start state. Q0 is the start state. From Q0 on input A, see Q0 on A goes to Q0 itself, Q0 on A goes to Q1. So Q0 on A makes a transition to two states. So Q0 on A goes to Q0, Q0 on A goes to Q1. So Q0 on A goes to Q0, Q1. Now from Q0, what about on input B? So Q0 on B goes to Q0. So Q0 on B goes to Q0. Now come to state Q1. Q1 on A is not defined. So we will take Q1 on A is 5. Q1 on B goes to Q2. So Q1 on A is 5, Q1 on B goes to Q2. So Q1 on B goes to Q2. Now look at the state Q2. From Q2 there are no transitions. So Q2 on A is 5, Q2 on B is 5. And then NFA is given to us. So we just call them as the states Q0, Q1, Q2. Now we are finding the states of DFA. The states of DFA, just to distinguish from NFA, we put them in the brace. So these are the states of the new, DFA. Whenever I am making the states of the new DFA, I will be putting them in the braces. Okay. Now what is the method for converting the given NFA to DFA? Come to step 1, identify the start state of the DFA. Since Q0 is the start state of NFA, the set with Q0 will be the start state of DFA. This is what I mentioned. See, this Q0 is the start state of a NFA. The same Q0 within brace will be the start state of the DFA. Now step 2, identify the alphabets of DFA. The input alphabets of NFA are the input alphabets of the DFA. So as far as input alphabets are concerned, there is no change. Sigma equal to A, B itself. Now come to step 3. We will have to identify the states of DFA. So identify QD, which are the states of the DFA. So what is Qn? Qn equal to Q0, Q1, Q2, right? So there were three states in the NFA, Q0, Q1, Q2. What are the subsets of this? The subsets of Qn would be 2 raised to Q. See here the number of states are 3, 2 power 3 is 8. So QD will be having 8 subsets. So its subsets are the states of the DFA. So the states of DFA are, it would be 8 as I told you. The empty state 5, Q0 alone, Q1 alone, Q2 alone, then Q0, Q1, Q0, Q2, Q1 comma Q2, then Q0 comma Q1 comma Q2. These 8 would be the states of the DFA. Now, after knowing the states of DFA, we have to identify the final states of the DFA. Now, what is the final state of NFA? Q2. Since Q2 is the final state of NFA, wherever Q2 is there, all the corresponding states become the final state of the DFA. So, FD would be Q2, comma, Q0 Q2, comma, Q1 Q2, comma, Q0 Q1 Q2. The set consisting of all these states wherever we have Q2 would be the final states of the diagram. Now, the last step, that is step 5. Identify the transitions of DFA, which is delta D. Delta D would be the transitions of the DFA. Obtain the transitions for each of the states of QD, which is obtained in step 3 as shown below. So, we are going to find the transitions now. For finding the transitions, we will have to consider each of these 8 states. Okay, I will consider the state 5 first, and then I will apply both the inputs A comma B. Then I will consider the state Q0, I will apply the input A comma B. Then I will consider the state Q1, for this I will apply A comma B. Then Q2 I will apply the input A comma B. So, the same process I will do it for all the 8 states. Okay, so I have kept it ready. For state 5, you will have to see the diagram each time, either the diagram or the transition table. Input symbol is A. So, we are finding delta D. So, delta D of 5 on A would be 5, because you are going on, this is 5 is, there is no transition. No transition on A would be 5 itself. Same way, if you apply the input symbol B, delta D of 5 on B would be 5. So, make the new transition table. Here we already know the states. Those 8 states are 5, Q0, Q1, Q2, Q0, Q1, Q0, Q2, Q1, Q2, Q0, Q1, Q2, and the inputs are A and B. So, now we got 2 transitions. Delta D of 5 on A is 5, that is 5 on A is 5, delta D of 5 on B is 5. So, 5 on B would be 5, this much we got. Now, what is the next state? The next state is state Q0. When you are in Q0, input symbol could be either A or input symbol could be B. If the input symbol is A, then delta D of Q0 on A would be, what is Q0 on A? Q0 on A is Q0 Q1. So, Q0 on A would be Q0 Q1. Similarly, input symbol is B. Q0 on B. What is Q0 on B? Which is Q0. Q0 on B is Q0. So, we did the transition for the state Q0. Q0 on A is Q0 Q1. Make this entry Q0 Q1. Q0 on B is Q0. So, we got this entry. You prepare the transition table, and as and when you find a new state, go on adding it to the transition table every time. Now, we will consider the state Q1. So, for state Q1, input symbol equal to A. So, delta D of Q1 on A. So, go there. What is Q1 on A? Q1 on A is 5. So, Q1 on A is 5. Come to input symbol is B. Q1 on B. What is Q1 on B? It is Q2. So, Q1 on B is Q2. Now, make these 2 entries. Q1 on A is 5, Q1 on B is Q2. Here we are going to write it. Q1 on A is phi, Q1 on B is Q2. Now we will consider the state Q2. For the state Q2, for the state Q2, input symbol is A. So delta D of Q2 on A. So from Q2, both the transitions are phi. Can you see? Q2 on A is phi, Q2 on B is also phi. So Q2 on A is phi. Now input symbol is B. Q2 on B is phi. So we will make these two entries. Q2 on A is phi, Q2 on B is phi. Now consider the state Q0 comma Q1. Input symbol is A. So now look at this, we have to find delta D. So delta D of Q0 comma Q1 on A, which is equal to delta N of Q0 comma Q1 on A, because the transitions would be equivalent. So now let us consider the state Q0 comma Q1. Input symbol equals A. So delta D and delta N would be equivalent. Delta D of Q0 comma Q1 on A would be equivalent to delta N of Q0 comma Q1 on A. So now we will have to split this. Delta N of Q0 comma Q1 on A can be written as delta N of Q0 on A union delta N of Q1 on A. So delta N of Q0 on A union delta N of Q1 on A. Now we have split this into two different transition functions. Let us see what is Q0 on A. Q0 on A is Q0 Q1. So Q0 on A is Q0 Q1, Q1 on A is phi. So Q0 Q1 union phi would be Q0 comma Q1. Now for input symbol B. Input symbol is B. Delta D of Q0 comma Q1 on B is same as delta N of Q0 comma Q1 on B, which is delta N of Q0 on B union delta N of Q1 on B. So this is delta N of Q0 on B union delta N of Q1 on B. Look at the first transition table and fill up these entries. Q0 on B is Q0, Q1 on B is Q2. So Q0 union Q2 would be Q0 Q2. For making these entries, we are looking at the first transition table. Okay. So Q0 on A, Q0 on A is Q0 Q1, Q0 on B is Q0 Q2. So now we will have to fill those two entries. So Q0 on A is Q0 Q1, Q0 Q1 on B is Q0 Q2. So we are done with these two entries. Now we will have to consider Q0 Q2. Let us consider the state Q0 Q2. Input symbol is A. So delta D of Q0 Q2 on A is equal to delta N of Q0 Q2 on A. So how do we write it? This is equal to delta N of Q0 on A union delta N of Q2 on A. So what is Q0 on A? From the first transition table, that would be Q0 comma Q1. What is Q2 on A? We know it is phi. So Q0 comma Q1 union phi is equal to Q0 comma Q1. Now for the same state, let us apply the input B. So input symbol is B now. Delta D of Q0 comma Q2 on B which is equal to delta n of Q0 comma Q2 on B. So, this is delta n of Q0 on B union delta n of Q2 on B. So, Q0 on B, from the transition table it is Q0 and Q2 on B is phi. Q0 union phi would be Q0. So, we got the entries for Q0 comma Q2. So, Q0 comma Q2 on A is Q0 Q1, on B it is Q0. We will have to fill these entries in the transition table. Yes, Q0 comma Q2 on A is Q0 Q1 and on B is Q0. Now, we will have to consider this Q1 Q2. Yeah, consider the state Q1 Q2. Input symbol equal to A. So, delta D of Q1 comma Q2 on A is same as delta N of Q1 comma Q2 on A. So, now we are going to split this. This is delta N of Q1 on A union delta N of Q2 on A. So, what is delta N of Q1 on A? From the transition table, that is phi. Delta N of Q2 on A is again phi. Phi union phi is phi. So, now we will have to consider input symbol B. Delta D of Q1 comma Q2 on B is same as delta N of Q1 comma Q2 on B. This is Q1 on B, delta N of Q1 on B union delta N of Q2 on B. So, Q1 on B would be Q2, Q2 on B would be phi, Q2 union phi would be Q2. So, Q1 Q2 on B is Q2, Q1 Q2 on A is phi. So, phi and Q2 are the entries. Q1 Q2, phi and Q2 are the entries. Now, the last state is Q0 comma Q1 comma Q2. Consider the state Q0 comma Q1 comma Q2. Now, input symbol is A. So, delta D of Q0 comma Q1 comma Q2 on A equal to delta N of Q0 comma Q1 comma Q2 on A. So, now we have to split this function delta N of Q0 on A union delta N of Q1 on A union delta N of Q2 on A. Now, for these entries we have to look at the first transition table. Q0 on A is Q0 Q1, Q1 on A is phi, Q2 on A is phi. So, Q0 Q1 union phi would give us Q0 Q1. Now, we will have to consider the input symbol B. So, delta D of Q0 comma Q1 comma Q2 on B is same as delta N of Q0 Q1 Q2 on B, which is equal to delta N of Q0 on B union delta N of Q1 on B union delta N of Q2 on B. Q0 on B is Q0, Q1 on B is Q2, Q2 on B is phi. So, Q0 union Q2 union phi would give us Q0 comma Q2. Okay. So, then we will have to mention all the 8 states. We will have to do the entries in the transition table. So, once we do the final diagram, we will see that the states Q1, Q2, Q1, Q2 and Q0, Q1, Q2, they are not reachable from the start state. So, those states can be eliminated. After eliminating those states, we will get this transition diagram. So, we will be left with 3 states Q0, Q0 Q1, Q0 Q2. By looking at the new transition table, we will have to complete this diagram. So, Q0 on A would be Q0 Q1, Q0 on B would be Q0, Q0 Q1 on A is a self loop, Q0 Q1 on B would go to Q0 Q2, Q0 Q2 on A would come to Q0 Q1, Q0 Q2 on B would go to Q0. So, this would be the final transition diagram for the subset construction method. So, using this subset construction method, we have converted the given NFA to its equivalent DFA. It means whatever strings the original NFA was accepting, the same strings the new DFA also will accept. Hence, they are equivalent. Thank you.